In this video, we're going to talk about file systems of an operating system, just to kind of go a little bit deeper as far as the file system is concerned. So, and we're going to talk about this, by the way, in light of the three basic flavors of operating systems that are kind of the most common, if you will. So, the file system is said to be interwoven with the operating system. It's really tightly coupled. Now, you're going to hear a lot about structured programming and decoupling your code so that it's reusable and modular, and all of those things are true. At the operating system level, however, the file system is used a lot by the system and by other things. And now we got to turn this shit down. Welcome back. In this short video, we're going to talk about the file system of an OS. I want to go just a little bit deeper in file systems because it's important, and I think it's worth, at least for the common operating systems that we talk about, it's worth knowing a little bit more for this particular functionality of an operating system. So the first thing I want to talk about is how the file system is interwoven with the operating system. And what that means is it's tightly coupled. In computer science, you're going to hear a lot about decoupling your code, making it modular, making it plug and play. So I can build a module here, and 6 months from now, I may be on a different project and go, you know what, I can use that module. So we like to code where there's not a lot of dependencies. With the file system in the operating system, however, it's pretty tightly coupled to the OS and what it does. I'm not going to go into why and how and all that kind of stuff because it's kind of, that's too deep, but I just want you to understand that you're not going to separate the file system from the operating system. It's a big piece of the kernel and what happens, okay? Now, modern operating systems, however, know that I may have a Mac and a PC, or I may have a Raspberry Pi running in Debian Linux or a build thereof, and I need to take a file from that and put it on my computer, my desktop. And so modern OSs allow access to different types of file systems, okay? So you're not going to be a very successful operating system if you can't read the file systems of other OSs, okay? And we'll talk about that as we go, but that's kind of a key point. Now, there's two flavors. There is textual, okay, which means I'm literally typing it at a command prompt, okay, and I can copy files, move them, delete them. I can do ls in Linux and see what's in the directory, things like that. Or in Windows or Mac OS, I can open up a folder or the file manager and look at them and sort them and do all kinds of things, okay? Graphical user interfaces, or GUIs, are how most people interact with computers. However, as a programmer, you are going to learn to use command shells or what looks like the old DOS prompts in order to hand type textual code to do things in a very rapid manner the way you need to do it, okay? So textual or graphical is how a file system is used on a computer. So let's talk a little bit about Windows. In the early days of DOS, and DOS stands for Disk Operating System, okay? It had what was called File Allocation Table 12, FAT16, and ultimately FAT32. Basically, that was a phone, it's like a phone book for your hard drive, okay? Because the way hard drives work is it just splatters wherever it takes your file and splatters pieces wherever it can find room. So you may have one program that's got a little bit here, a little bit here, a little bit here, a little bit here, in fragments. And if you've ever heard about a hard drive becoming fragmented, it means you've got all of these little pieces all over the drive. And the heads, when it was a spinning drive, you used to have to go and read a little here, move over here, read a little, move over here. And it could take time if you had lots of little pieces. So you could run what was called a defragger, and it would take, I remember walking away or having to go to bed at night, and it wouldn't be done till the next morning, where it would literally erase part of the drive, and it would start with the most commonly used that isn't going to change files, and it would write them contiguously, right? And then out towards the edge, it would get the files that you change a lot. And it would really speed up your computer. Now operating systems do this in the background for you automatically as part of the file management system. The problem with FAT was you could not have a file bigger than 4 gigs. And anyone who's made a video these days or a large PowerPoint, you can blow through 4 gigs pretty quick. So they had to come up with what was called NTFS, which stands for Windows NT File System. Because when they had Windows NT, way before Windows 8, okay, that was kind of the business version of Windows at the time. Windows NT is where they developed the Windows NT FS system, okay? Now, it supports a couple things that I want to talk about. Metadata, which is information about the file, okay? When it was created, who created it, what the permissions are on the file, all stored in a little metadata file, okay, controlled by the operating system. And it also allowed those metadata to be used as access control lists. So I can make it so that you can't see a particular file. And journaling, which is kind of a history of what I've done with the file. Now, all of those are handled by the file system so that if I go Control Z after I delete something, it comes back, okay? It allows you file recovery, and it provides safety so that you don't inadvertently wipe out files without some level of control, okay? Now let's talk about Mac OS. Mac uses the Apple file system. They spend a lot of time naming that, right? APFS, all right? And Mac OS, which has an extended HFS Plus, are the two that you're going to see frequently. But then you're also going to see this exFAT, which is a file system that is compatible between Mac and Windows, okay? So if you've got an external flash drive, sometimes people will use exFAT on that because you can move between a Mac and a PC. All right, it allows Unicode use of file names. We're going to have a video on ASCII, and we'll refer to Unicode, and I'll get into that later. Unicode is much larger than ASCII, but we'll set that aside for now. And it is very metadata rich. The one thing that Mac OS does very well is metadata about your files. There's a lot of information about the file that's stored in the metadata. It also supports Unix permissions, which is read, write, modify, delete permissions, and it also has journaling. Now, the newer versions of Mac OS can also read FAT and NTFS, okay? So as the operating systems get more and more advanced, they're like, you know what, we're going to read our competitors' mail. We're going to make it so that it just doesn't matter. So if you really have the latest Mac OS or the latest Windows, you can cross-read these files, okay? This used to be a much bigger deal. And the third one we're going to talk about is the Unix, Linux, Raspberry OS world. Unix was the pay version of the operating system. Linux was the open source replication of Unix for free. And Raspberry OS is now the new version which grew out of Raspbian OS, which was a version of Debian Linux, okay? And there's a bunch of flavors of Linux. There's Red Hat and Debian, just to name 2 of them. All right. In Linux, you have to mount a drive. You have to attach it, if you will. It has to be mounted. Now, the root drive that has the OS is auto-mounted, okay? But to many people's annoyance, you have to mount a drive to have access to it to see what's on it. This literally goes back to the days of reel-to-reel tapes, where they'd have these massive tapes, and they would have to mount the tape in order to read the sequential file that was stored on the magnetic tape. Okay? Root files, like I said, are auto-mounted. Now they have utilities that will detect when you plug a thumb drive or a new hard drive or anything in the USB, it'll detect it and auto-mount it for you. Why? Because every other OS in the world makes it easy So Linux had to catch up. Okay? And it is so widespread that it now supports a number of file systems, but it still primarily runs like Unix. And the Raspberry OS came out of Raspbian, and it is a derivation of Debian Linux. It's kind of come into its own very, very recently, so it's going to be interesting to see how that develops. Now, when we talk about file systems, we need to understand what file formats are. And as a programmer, there may come a time in your career where you create your own file format. Okay, it happens all the time. There's some common file formats, however, that you should be familiar with. The first ones are called executable files. These are programs that you can run. So when you double click the Word icon, you're not telling the operating system, here's a picture of what I want to run. The operating system is looking for word.exe. It's an executable program. So it will run WinWord, is what it's called actually, and it will run the program. So if it ends in .com, .exe, or DLL, it is compiled machine instructions that can run. Remember, the definition of a program is nothing more than a series of instructions that a computer executes. That's it. Okay? It's a series of instructions that a computer executes. That's a program. If you want it to be runnable, here are 3 of the common file formats that are executable. Now, let's talk about Office. We use that a lot, right? Older versions use DOC, XLS, and PPT. Guess what they stand for? Doc for document, Excel spreadsheet, and PowerPoint. The new versions that have gone away from, they've gone to more of an XML structure to them, have added an X at the end. So DOCX, the parentheses are just to show there's 2 flavors. So DOCX is a modern version of a Word document file. Okay? XLSX, PPTX. Okay? And then web pages, notice that this is not a programming language, it's a file format, HTML. You'll also see that abbreviated sometimes as HTM. CSS for cascading style sheet. CSHTML, this is getting different now. This is a C# HTML file, which is a new .NET Core hybrid between the file format of a web page and a C# page. So that gets a little weird. We'll talk about that in our advanced classes. Now, images. There's all kinds of image file formats. JPEGs, GIFs, PNGs, bitmaps, TIFFs. Some of these are lossy, meaning it uses run length encoding. We'll talk about that later. But that means that if you keep saving the same file, you can actually lose quality of the image over time. And then you have bitmap and TIFF, which are lossless, which means it's the same pixel pattern stored to disk every time you save it. You're never going to lose the information. It's just going to be really, really big. Okay? And so among the different file formats, if you're going to say use an image on a web page and you want it to load quick, you may want to use a PNG that's got some compression to it. Okay? So these file formats are handled with your file name in front of the period by the operating system. Okay? So if I say, file save, my homework.docx, the file system is what's going to make sure that it ends up on the drive that I want it to. If I want to copy it and then make a new version for tomorrow's homework, whatever, templating is a good idea with file formats. The file system is how I get that done. Okay, in the next video, we're going to begin to talk about how do we get computers to talk to each other. So that's going to be a lot of fun. We have completed the series on a given computer and what's in it, how it works, and what the operating system and the file system will do for us. So now we're going to kind of move up a little bit and say, how do we get these things to talk to each other? And we're going to end that series with basically how the internet works. Okay? So it's going to be a lot of fun. I'll see you on the other side.